Hi everybody, myself Dr. R. Balamurugan, working as an associate professor in the Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. I'm going to explain about introduction to power electronics. Let's we explore the slides. The outline of my presentation is we are going to see about what is power electronics, what is the necessity of power electronics circuits, and classification of power electronic circuits, and how it is interfaced with other generating systems and other circuits, and what are the real enablers of power electronic circuits, and the application of power electronics. Then the importance in modern electrical landscape, challenges in power electronics, and future outlook. So before going to see about the power electronics, we have to know about the difference between low power electronics and the power electronics. So low power electronics, we will be operating in low input voltages, and the doping level will be very low. And for high power applications, we will be handling the high voltages. So the doping nature should be very high in order to withstand the high voltages. So the semiconductor switches like MOSFETs, IGBTs, thyristors, or high power devices, the doping nature will be changed in order to handle the high power conversion and conditioning and processing and control applications. So here the electrical source and the load will be connected by using these high power electronic circuits to have a conversion and control over the applications and um, process. So why power electronics is needed? So in order to have a fast and more efficient and compact circuits and highly reliable and easily controllable digital circuit and microcontrollers, we are in need of a controlled semiconductor switches for power conversions. So this give a high efficient power conversions, because in earlier days we are using motor generator sets, mechanical regulators and rheostats, which are bulky and which have more losses. So in order to remove those losses, we are preferring the power semiconductor switches, which give power electronic circuits. This will be a more compact and more efficient, and will be a faster in working. So the major classification of power electronic circuits are converters, inverters, choppers, AC voltage controllers, and cycloconverters. So converters, in the sense, it is also known as rectifiers. Here AC power is converted into DC, and inverters DC will be converted into AC, and choppers fixed DC voltage will be converted into variable DC voltage. Likewise, AC voltage controllers can be defined as AC fixed voltage with constant frequency will be changed to AC variable voltage with constant frequency. Same way, cycloconverters is also an operating in AC voltage. Here, AC with fixed voltage, fixed frequency will be changed to AC with constant voltage, variable frequency. These are the basic classification of power electronic circuits. So let's we see how power electronics will act as an energy interface for the other systems. For example, you take the solar PV models. The connection between solar PV models and electrical grid will be done by using the power electronic circuits, so that the voltage will be boosted or regulated in order to supply with the grid. Likewise, battery storage devices, battery storage and electrical motor, like you can go with electrical vehicles, we are in need of power electronic circuits in order to have an interface between the battery and the electrical motor to operate as an electrical vehicle. Then third one is an high voltage DC transmission. So in order to have a lossless transmission, we are in need of a DC conversion. So for that, power electronic circuits is highly needed. So next one is charging infrastructure, because electrical vehicles are booming right now. So the charging infrastructure is very important, and it has a power electronic circuits or power electronics interface with utility or any renewable energy systems with the electrical vehicles. So here power electronics plays a major role in connecting smart grids, microgrids, renewable energy systems, EV charging networks. So how these power electronic circuits will work? So with the help of the semiconductor switches. These semiconductor switches, we call it as a real enablers, because these devices, we have generally two types: uncontrolled devices and controlled devices. Uncontrolled devices is nothing but it will be turned on without any control over conduction. So that will be done by using the power diodes. Here there will be no control medium. When it reaches the cut-in voltage, it will be turned on without have a control over the conduction. So next, controlled switches, we will be enabling the devices by using the gate terminal, and thyristors, power BJT, MOSFET, IGBT, and IGCT will come under this category. Next, recently we are having two types of materials used for having more efficient power electronic circuits. Those devices are silicon carbide and gallium nitride devices. These devices will offer high switching efficiency, higher efficiency compared to the conventional doping devices, and it operates at high temperatures. For example, in industrial areas, temperature will be more, and also when we see about the battery operated vehicles, the operating temperature will be more. And next, it will be smaller passive components only needed, and the overall circuit is also compact for higher power densities. So when one thing you have to remember, when switching frequency increases, the size of magnets and capacitors filters shrinks substantially. This is why the SMPS switch mode power supplies are extremely compact right now. So this slide shows some of the power electronics application you can see in different mediums: renewable energy, industrial automation, railway traction, aerospace and defense, consumer electronics, and electrical vehicles. In all places, these power electronic circuits plays a major role in conversion of energy and utilization of energy. So these I have given the applications. Everyday consumer electronics, for examples, fan regulators, dimmers, AC controllers, micro one, UPS, etc., and laptop chargers, phone chargers, etc. Industry and utility systems, control over the pumps, fans, compressors, etc. And power systems, high voltage DC transmission, as we have already seen. Industrial process in the building, induction heating, arc furnaces, etc. So in transportation, we all know electrical vehicle and electric tractions and automotive applications. Renewable energy, the conversion of energy from solar to that is DC to AC for connecting with the grid, and wind also for regulating the voltages. We are in need of power electronic circuits. Likewise, aerospace, telecommunications, we are in need of power electronic circuits for utilizing the energies. So in modern electrical landscape, the importance of power electronic circuits is it offers high efficiency, smaller size, and also gives lower losses, greater controllability, and very important thing is bidirectional power flow control in batteries and renewable energies. This supports the applications to give high efficiency for the end users. So even though there are many advantages, there are some challenges in power electronics. Is first thing is managing the harmonics and EMI interferences. Then second thing is thermal management. The third thing is reliability in working in harsh operating conditions, protection against faults and transients. Then compatibility with grid standards. Future outlook. So future, we already I have given that wide bandgap devices are booming right now. So you have to adapt those devices for having efficient operation. AI control is needed for prediction and diagnosing the fault which is occurring in the circuits. High voltage enabled converters, smart converters we can say it. Solid state transformers, wireless power transfer, high frequency power distribution is needed, and speed of electrical mobility and DC microgrids. These are the future outlooks for power electronics, which is much more needed for for the end users. Thank you for giving this opportunity to brief about the introduction about power electronics. Thank you.